So thank you everyone for having me. Today I'm going to be talking about how to compile your own language to WebAssembly. And maybe you're thinking, well, I'm not interested in doing that. Honestly, I think more people, the more people that I've shown these sorts of techniques to, the more they're like, whoa, I never realized that compilers are actually kind of really fun to do. I've gotten a lot of my friends into kind of toying around with compilers and parsers and those sorts of things as well. So I would say keep an open mind. But a little bit about me before I get started. My name is Jay Phelps. I'm the VP of Engineering, co-founder at a company called Outsmartly. And we're just coming out of stealth mode. We're aiming to basically make your website faster, no matter what it is, whether it's a Shopify site, whether you've already done a ton of work and made it a Jamstack site, we can still make it faster without any effort. And then also we can keep it fast as well when you can do A/B testing, personalization, other dynamic content, even with the Jamstack and keeping that performance. So that's our goal. If that's interesting, you can go ahead and reach out to me. I'm also available on Twitter where I talk about various stuff. Compilers, parsers, reactive programming, random developer thoughts. I'm at _J Phelps. So let's jump right in because we have a lot to cover. So we're going to build a toy language. And toy language just means that the language doesn't really do anything particularly useful, or it's like, people aren't going to actually use this, but it at least gives us the building blocks to understand how the basics of you might start getting into writing compilers. So the first thing when you're going to develop your own language is you need to decide, generally speaking, what do you want it to look like aesthetically? There's a lot of languages out there for you to draw inspiration from, and you can learn from past mistakes. I think that's probably one of my favorite parts about language design is that, you shamelessly steal from other people, like Swift and Rust and all these different, in Kotlin, they're all sharing and stealing from each other, making the entire ecosystem better. And I encourage you, you might be creating the next language that's the next Kotlin or what have you. There's lots of potential in these sorts of things. But since this is WebAssembly, and since JavaScript is one of the most popular languages out there, today we're going to make JScript. And it will look a lot like JavaScript. And so here's an example of a function. And for at least the very beginning, we're just going to have basically return statements, and you can return numbers, integers basically. And that's all we're going to work on, at least initially. If we have extra time, then we might go into other things. So the important thing you need to realize about WebAssembly, though, is it is a bytecode instruction set. It is not compiling to JavaScript or to some textual representation. It is compiling to binary. So WebAssembly files are actually binary. But you may be thinking, oh no, I don't want to have to deal with binary at all. Like honestly, don't worry at all. Lean on tools like LLVM, Binaryen. There's a whole slew of community tools. These two are the most popular. LLVM is very, very robust. However, much more complicated than Binaryen, especially to get it working correctly. It has a very high, very steep learning curve, whereas Binaryen is very full-featured, yet much easier to approach. And the kicker is that LLVM is able to target other target environments other than WebAssembly. You can target ARM and x64 and all that stuff, whereas Binaryen only targets WebAssembly, or at least that's the primary goal of it. It has other tooling for like compiling WebAssembly, JavaScript, and stuff like that. But Binaryen is production ready. AssemblyScript is a language that compiles to WebAssembly that uses a TypeScript-like syntax and semantics, and it uses Binaryen under the hood. So it's already a pretty popular library, and a couple other languages use it as well. So what is Binaryen? Well, it's a library, and it's actually a set of tools, but the primary thing, and the thing we're going to use today, is a library that compilers can use to generate WebAssembly from what's called an abstract syntax tree, or AST. Very few people will say abstract syntax tree because it's a long thing to say. So let's say AST. And that just basically means a tree representing the syntax in an abstract way. And you'll get a better idea here in just a second. So I think instead of showing you a bunch of slides, I'm going to do something that I swore I would never do again. I'm going to do some live coding. So wish me luck. All right, so I'm going to stop sharing this, and I'm going to share my editor. All right. So now that I'm sharing my editor, and if anyone can't see this, go ahead, definitely jump on and let me know. But so we should be seeing my editor. I've got a text file up, and I'm gonna write in JavaScript. Binaryen is actually written in C++. It has bindings for C, which can make it so that you can use it in almost any language. And then it also has a build which is compiled to WebAssembly JavaScript and has bindings to the JavaScript, and then it's published npm. So if you could just do npm install Binaryen and JS, I think it is, or I think it's maybe just Binaryen actually, and then you'll get it and be able to use it from JavaScript. So the other thing I'm going to be doing is using something called nodemon. So nodemon is Node, except for it'll automatically watch the files that you touch with this, or you can give it like directories to watch, and it will just automatically rerun the Node process, like restart it, kick it. So that's super handy for us today because we're just going to just run that, and now I won't have to touch the terminal again. So let's get started. The first thing that is involved with creating a compiler is parsing the syntax, parsing your actual string inputs. You can't, there's usually two conceptual phases: tokenization, also known as lexing or lexer parsing, and then there's the actual parse phase where it takes the tokens and translates that to an abstract syntax tree. Sorry, I lost my train of thought. In practice, a lot of people kind of combine the two phases into basically like a parser that happens to do lexing at the same time, sort of thing. And that's what we're going to do today because it's simpler. So we're going to create a class called parser, and we're going to instantiate it because that's what we're going to need to do. Let's actually make a main function just because it'll help us later. And we'll just call it right away. But we'll create a new instance of a parser. And we're going to create a function a method called parse. It's going to take input. It's going to assign that input onto here. Let's go ahead and give it a default. And then we're going to have default index to keep track of where we are when we're traversing this string, because we're going to go through each character in this string and generate an abstract syntax tree from it. So we want to reset it every time you call parse. Now, within here, we need to start doing actual parsing, right? So one of the things we could do is we could create a read function. And inside here, we could create this little char, and we could say input index. And then we could log this out. I'm going to be doing a lot of logging because that's how I like to build compilers. I go and I'm just a constant REPL of logging. So let's say read, and we're just going to return this. So undefined, because I'm not actually, oh, wait, input index, read, parse. Oh, yeah, because it was empty. Duh, it's an empty string. So if I put like an empty space or something like that, it'll go there. One thing I like to do, so I do station Stingify. That way you can see white space and new lines much easier. Like it's more obvious that you're doing that. So first thing we probably want to do is actually check whether this is actually empty, like whether we've reached the end of the file. So let's make a method for that because we're going to use this a lot, actually. And we're going to just say, there's lots of ways to do this, but we're going to just say if the index that we're at is greater than or equal to the input length, and then we can say if end of file, that's what EOF stands for, end of file. It's a convention that's commonly used. We're going to return a token. This is the shape of the tokens we're going to use today, where it's an object with kind and then the actual kind of token. And so if it's an end of file, we'll just return that. So we're no longer logging that out. And when we read that, we'll get the result. We'll say AST, but in fact, it's actually just a token at this point. Log that out. We see end of file. Cool. We're good. So next, we want to do white space. Now notice we're reaching the end of the code, but nothing's happening. We're just getting undefined. So what we want to do right away is create this little error handler. So if we don't recognize what's going on, we need to say unexpected And there's a whole talk on like best practices for debugging with syntax and all that stuff. But today, just for simplicity, we're just going to do something really simple. So unexpected character. We're going to JSON stringify it so that they can tell if it's new lines or what have you. So there we go. Unexpected character, white space, right? A single character, because we're not skipping white space. So that's what we want to do. Let's make a method called skip white space. And with here, inside here, we're going to say, while we're not at the end of file, you're going to see this pattern a ton. While we have not reached the end of file, check to see if the current character, so like this exact same code, check to see if the current character matches. And by the way, I'm going to use regular expressions just for simplicity, so I don't have to explain other things, but it's not the most performant way. Usually you're going to want to use like character codes and stuff like that. You'll, as you dive deeper in, you'll see those sorts of things. So /s is for white space. So if it is not white space, go ahead and break, meaning we're just going to stop. Otherwise, we're going to increment our index. So we're going to go until we've reached non-white space. And so we can say skip white space, end of file. Perfect. We've got end of file, right? So that way, if I do all this, we're still, doesn't matter how much white space or where we put it, we've now skipping it and we've reached the end of file. Excellent. Next up, the goal was to work on functions. So let's go ahead and do that. Let's start to write what a function would look like. So in here, let's say function main, and it looks like that. So if we go here, we're going to say unexpected character F, right? We didn't expect that because we're not currently reading keywords and identifiers and stuff like that. So let's do that. Let's do that. So let's first start by saying read identifier. It'll just be easier this way. So read identifier. And to do this, we're going to need to know two things. We're going to say is identifier start and is identifier part. And that basically, we're going to have a difference between the start of an identifier and the parts of it. Like after, because for example, in an identifier, you can have numbers, but it can't be at the start of it. It can only be at the inside after the first character. So we'll just use regex again, much easier for now. So we'll say Z, and then so the start only works with that. We'll say underscores as well. And then for parts, we'll say, just for kicks, we'll add the 0 to 9. And you could compose the two. That's what commonly does, but I'm not going to do that right now. Cool. So what we need to do is check this. So we say, if it's identifier start, and let's just say read identifier, I'll return it, throw to do. So we should get, okay, cool, whoops. Awesome, to do, perfect. So now we want to read the identifier. Now this is gonna be the first time where we're actually creating a token that's longer than a single character because we just have end of file. So let's do the start because we know right now the current index is in fact the start of the identifier. And then we're going to do our pattern of our while loop. So let's just copy pasta, save ourselves some time. So you notice how we're going to do this a lot. So let's just make a helper. Let's extract this. Right. Now it's as simple as calling this every time we want to do it. More here. Cool. All right. Looks like I've got a syntax error to write before here. Cool. So now we want to check, is the char not white space, but as long as it's not is identifier part. So if it's not, then we do that. Now we're going to actually go into the, oops, there we go, input slice from the start to the index. And we're going to create a token of identifier. We're giving that just a generic name, and then we pass in the actual value. So now, boom, we got identifier. Now notice I'm not getting any error that the rest of this code is here, and that's because we had this hard-coded read. Now we want to move on to doing something a little bit more complicated. Let's do it this way. Let's say tokens, return the tokens, and we'll do our while it's not end of file, which we do a lot of. Token, and then we'll push the token in there. And we get our unexpected character this, right? So because what actually happened is it picked up this, it thought it was an identifier, picked up this, thought it was an identifier, then it reached here. Now, before we go too far, we want to check, so this is supposed to be a keyword, not an identifier. And this is a common, you can do it a lot of ways. A common pattern is to do something like this, where under the hood you have this, and then you do something like switch, or you create a dictionary kind, or excuse me, value. And then you say, you just create a list of keywords. So function is going to be a keyword. And in that case, we just say kind token value. And now we've got that as a keyword. Now we need to move on to unexpected token M. Yeah, so we read that. Oh, oops, I know what I did wrong. I forgot my default. I bet someone out there is going, oh yeah, I'm glad he noticed. All right, there. Now we're back to our missing of brackets. So now we need a whole new switch. We need a switch to go and say these special characters that we're going to know. So let's just pound them all out right now. We know that we're going to need that. We know we're going to need curlies. And if whenever we reach that, we're just going to say the kind of that character. That's going to be it. Now, you notice right now we're not getting anything, and that's because we're in an infinite loop. This is not reaching the end of file. We're in an infinite loop, and the reason why is skipping white space. This is a complexity. There's a lot of ways to handle this. It really depends on whether white space is important in your language or just uses it to delimit tokens. And so for today, what we're going to do is just going to rename this to read without white space, just for simplicity. We're going to make another method, and we're going to just call it read. And then we're going to skip white space, say token, read without white space. Skip the white space again, and then return the token. And that way we, oh, it's not working. Why is it not working? See, this is the fun thing about compilers. You get the debugging. I bet someone's out there going, what is going on? Let's see what happens if I reach here. So it doesn't reach that. Token, kind of car, identifier start if it's end of file. Read the char. Otherwise, while it's not end of file, return the tokens, push the token, read, skip the white space, then read without white space. Okay, let's see what's going on here. See if we reach here. We'll do a little debugging. So, whoa, see, you can very quickly see what the problem was. That is infinitely looping on there. Oh, and that's because we're just not consuming. So someone probably also noticed that. Boom. So we have to actually consume that character. Whoops, my bad. So now we got function, main, we've got all those tokens. Now we want to do something like this. So we could do return and do all that. But for now, just for simplicity's sake, I'm going to start with just doing the declaration, because I think it'll make things easier for us. So we've tokenized, but we're not doing parsing. So let's change this to body node. Whoops. Instead of read, let's say parse top level statement, and we'll make this method here. And then here, we're going to change. Now we're making our first AST node. So this is an AST node, and we're just going to call it script, because this is like the top level thing. And a script has a body, so it has a number of statements that are top level statements. And so we're just going to loop through those. And whenever we're doing these statement type of things where we loop through, very common, you're going to have this sort of pattern where you need to do some sort of peeking, which we need to write. We haven't done that yet. And then you're going to switch. You're going to big switch on the different values. So we'll say default and throw new air, expected top level statement, but found token kind. Now we'll see that peek is not defined, so let's go ahead and make that. Peeking is basically look-aheads. So let's do that. We only need, for this example, we only need one look-ahead. We don't need multiple. So let's do that. How are you going to do peeking? Well, the easiest way is to actually read the token and then assign that token, storing it, and then returning it, right? Now, you don't want to, every time someone peeks, you don't want to keep reading. You need to check, do you already have a look ahead or not? So if you don't have a look ahead, we'll go ahead and make one, store it, and then return it. But if we have one already, we're just going to reuse the same one. So we have one look ahead position. Now, if I hit save, we say expected top level statement, but found function. Let's JSON stringify this just so that easier for us. Sweet. OK, now let's go say function, turn parse function declaration. Okay. Make a parse function declaration. Now at this point, we're still infinitely looping because we're not actually consuming this. So we need to create a match function where we're actually going to consume the token and match against it. And if it doesn't match against it, it throws an error. So we say kind, and then we take the token. Now, remember we just created peek? Well, inside of our read, we're not actually reusing that. So we need to check, do we have a look ahead? And if we do, we need to pull it out and then reset it like that, because you actually want to use and consume that look ahead if someone actually does read it. That way, when we go here, it doesn't matter whether there was a peek look ahead or not. So within here, we just say if token kind doesn't equal the expected kind, we're going to say throw new air, expected, JSON stringify, kind, but saw, JSON stringify, token kind. Okay. Expected undefined, but saw function because we're not actually passing anything. So now let's actually pass it function because that's going to be the first token we want to match against. So boom, it matched it, but then it found the identifier because we haven't consumed anything else. That's the next thing. We need to actually match the identifier. So match identifier. And now we've got the parenthesis. Close parenthesis, the curly, and I'm just going to skip them and just keep doing it. Boom, and now we're done, right? With that, now notice we have that undefined in the body. That's because we're not returning this function declaration. We'll say body. That. Now we've got function declaration, but it's empty. Now we're going to need this inspector here in just a second. So I'm just going to replace this real quick, or just so that we deeply log that whatever the value is out. So back to our function. We want to actually store, we want to actually get the value of this. So let's go to match, make sure that match is actually returning the actual token itself. So when we get match, we're going to get the actual identifier token. We can just pass that there. Now you'll see that we've got function declaration, the name is main. Perfect, that's working well. Now, next up, so we parsed that, and we're ready to actually start parsing things for the body. So we wanted to do return, and then an actual number with a semicolon as your statement. So we expected this, but we saw identifier. Now we need to create a function called parse statement. Or you could say function statements or whatever, however you want to describe it. But basically, we're saying statements that are allowed within function bodies. And inside here, we're going to do that same big switch. So we're going to peek, switch, token, kind, case, return. That's going to be one of our first ones, right? So we're going to parse return statement. And let's just copy pasta this. Expected statement, but found. Right. Now let's start using this. So within here, after we've got the entry, we're going to do our big not end of file loop. And in here, we want to say if peek kind equals this, we break, right? Because if we close, we might not actually have anything inside the body. It might be just an empty body, in which case we don't want to do anything. But if we do, we'll say parse statement. Oops. Right, and then we'll push that inside there. Now, this is going to be common later, so let's go ahead and actually extract this out to parse block. Make this a new one and call this block body. All right. So we parse the statements, there, peek in there, we match that. If the kind of that, we parse the statement, we push the child. Let's go ahead and remove this for now. So the statement but found identifier. What was the identifier? Let's expected statement but found. Go ahead and move that out. Token value. Return. So it's not actually working. Why is it not working? Parse return statement. So let's take a look. So we peeked. Identifier return. Oh, so that's a dumb problem. We just haven't made it a keyword. So simple enough. Come in here, make it a keyword. Now it will work. Now parse return statement is not a function, and that's probably because we named it differently. Oh, we just haven't actually even, I'm sorry, we haven't even made it yet. That's funny. So here we go. We're going to match the return. Body is not defined in parse block, which is easy enough. We just need to make one. And boom, we've got that. Now, and you'll notice that the body has undefined inside the block, which is not ideal. So if we say if peek kind is this, we break and then we match it. Why is that undefined? It's undefined. We peek the kind. We parse the statement. Let's take a look. I'm going to stop logging this for a second. Okay. Return, we get return, and then we get this, which is not what we wanted. So why? Oh, that's easy enough, because we're not returning this. Keep doing that, which is funny. So for now, it's just going to be that simple. We're not going to accept an argument. Just make sure that works. Perfect. Now we do want to accept an argument. That means we need to actually start parsing numbers, which is easy enough to do. We come here, we just add another one. So we just say read, come back to here. We say if the char is matching 0 through 9. Then we're going to read number. And this one's going to be almost the same as reading an identifier. So we're just going to copy pasta. And so instead of identifier part, we're just going to do that match of that number here. Same deal as before, and we slice it. And so instead of saying value, we're going to call this raw, because this is the raw string of the number. And value is going to be actually when we convert it into a number. We parse it as a true number. Now, we expected a statement, but found identifier. And we incorrectly, oh, that's why, number. Cool, so expected statement found number. So now we actually need to go to parse return. We need to actually parse the argument, which is going to be parse expression. To actually make that, since we have not yet. Big switch. Happens a lot. Number. Parse number. And let's copy this just to save ourselves the time. You can always come back to this later if I'm going too fast for you. So expected expression, but found this. Awesome. Now we just need to create a parse number. Or token, actually, I'm sorry. So match number, return, find number, literal. Change that to number literal. And then let's destructure, simple enough. So we'll just do that raw and value, and then say raw and then value. Sweet. Now we just have semicolons. Now we're going to be too cool for school, and we're going to make semicolons optional, just for fun. So to do that, it's pretty simple. We just need to create a new function called parse statement. Rename this one to parse statement without semicolon. Probably you're seeing already what I'm doing. Node, parse statement without semicolon. So if peak semicolon, which is not in the, let's add that real quick. The character. If it's that, then we're going to go ahead and match it, consume that semicolon, and then return the actual node. Boom. So now if I come here and I change and I say, nah, I don't really like a semicolon. Why didn't it work? Interesting. So if we peek, oh, I totally screwed that up. Because sometimes I make a peek match, but today we're not going to. There we go. Now it can be either. So optional semicolons, but I like semicolons. So, well, in JavaScript and other languages I don't, but I like it in JavaScript. So now is the time to do actual code gen. We've got AST, that's what this is, our abstract syntax tree, but we need to actually generate WebAssembly code. And this part actually isn't very hard at all. Parsing, honestly, in this example was harder than our code gen is going to be, because Binaryen does the heavy lifting for us. So let's go ahead and create a code gen class. We're going to call it CodeGen Visitor because we're going to use the visitor pattern. It's very common in compilers. We'll create a visitor, a visit function. Go ahead and create CodeGen, new CodeGen, visit the AST. And for now, I'm going to comment this out. We'll see what is the return value of CodeGen. So right now we just get that return value of visit, I mean. There we go, it's nothing right now. So inside visit, a common pattern if you want to do things type safe, a common pattern is what's called double dispatch, where the AST nodes actually will then call, like it's kind of confusing to explain, but the visitor calls a dynamic virtual function on the visitor class, and that function then calls calls back into the visitor. Basically, it just makes it so that it's type safe. This is JavaScript, so we can get away with some hacky stuff. So that just makes things simpler for us. So let's just say method name, and we're going to say visit, and then node kind, right? Because that will, if we log that out, we'll see visit script. So let's actually create a visit script method. Say throw to do. Here, let's say if this type of this is a function, actually call it and provide the node. Otherwise, we'll just make our little helper here again and say unexpected node kind, node kind. Oh, to do. Now inside to do, let's do our logging again, because I log while I'm building these sorts of things. It's just so much easier. So we see that we need to go and visit. We're going to basically traverse the tree. That's what we're using the visitor for. So we need to visit the body. So if we call visit node body, what are we going to get? We're going to get unexpected node kind undefined. And why is that? That's because if we undo all this again, remember that this is an array of things. So one thing we could do is just loop. So let's say child of node body. Log that out. Child, bingo. Now let's visit them. Now we're getting our first unexpected node kind function declaration, and that means we need a function declaration thing to visit it. Right. Node. Cool. Now before we go any further, let's actually introduce Binaryen to the mix. So let's import it. And I'm not going to cover all the documentation. I'm more just going to kind of use it and then kind of discuss it while I'm using it. So I'm going to use this pattern. I'm going to say Binaryen module, and it'll be a class property. And once it's done finishing visiting the script, all these visit functions are always going to return a Binaryen object of some sort, part of the tree. And the visit script is going to return the actual module itself. So if we were to see how we're logging the result of the module, this is everything that's on Binaryen's module class that we created. And if you want to see something cool, if we say emit text, we immediately already get a WebAssembly module. We have a WebAssembly module. This is a textual representation of WebAssembly. WebAssembly is binary, but there's a textual representation because reading binary is like, stupid and impossible. So, or impractical, I guess I should say. So there's a textual representation, and that's what emit text will do. If you say emit binary, you get the actual binary, and that's not helpful, right? So we're going to say emit text for our debugging purposes, so we can keep track of what our result is. Well, we're visiting the function, but we're not actually adding the function. Easy enough. We need to say module, and this is on Binaryen again. It has a function called add function, and I highly, highly, highly recommend VS Code because even though I'm using JavaScript, look at that. It has auto-suggest for everything. It already knows and suggests all the stuff. Hugely, hugely, hugely helpful. So check out the params. We got name, params, vars, body. So we need name as a string. Well, name is right here, and it's inside the identifier. So, well, there's a lot of ways we could do this. Well, let's just do it this way. So let's say node name and then value. We'll just pull it, reach into there and pull it right out. Now, if we went ahead and saved this, we're going to get an error because cannot read length of undefined. It's some internal Binaryen thing. It is a little tough because Binaryen was written in C++. Some of the errors become difficult to grok, but you kind of get the hang of it once you have kind of fumbled around for a while. But the gist is that we need to pass these rest of these things. I'm not going to cover this, but there's the types for the argument, for the parameters, which we're not doing. The next one is the results, which is the return type. For now, for the hello world of us, let's just say none. 1 second here. So we'll just say Binaryen none. This is the type, and we're going to say the function basically doesn't return anything, just for now. And then the number of vars, which is nothing, and then the actual body itself. Now you have to, even though WebAssembly doesn't require a body per se, the Binaryen AST does. So you need to create a block for now, and we'll just have it be empty. So we're generating we have an AST, and then we're generating an intermediate AST for them, like for Binaryen. This is Binaryen's intermediate AST. And so let's see here. So blah, 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 blah. We're still getting length of undefined. And why would we do that? We're going to create type, return type on the bodies, and body number. Oh, that's right. So block, I forgot the first thing is that block is the first one's a label, optional label. In our case, we're not using it, so I'm not going to cover it. If I hit save, boom, we've already got a WebAssembly module that has a main function. However, it's not callable from the outside world yet. We need to actually export it. So we can add function export. And internal name and external name, they're going to be both the same in JScript. And now we see the entry for export name, name. Before we get too ahead of ourselves, let's actually verify that this is in fact a real WebAssembly module that really does work. So we'll say instance WebAssembly instantiate the binary. Now, if we log out exports, saying exports of undefined, oh, yeah, that's right. We have to await. So let's change this to an async function. You await the instantiate. I'm not going to cover those sorts of things because it's outside the scope. But there, boom, we see the main function. So if we call it, what do we get? Undefined. Because right now, look at that. The function doesn't actually return anything at all. So let's move forward with making it actually return something. So remember how we've got this block here. So let's go ahead and actually do this. Let's say body, and we're going to go ahead and visit the body. Node body, and we should get an error that we're not visiting. Yeah, we have no visitor for block. So we'll do module, block, no label, and then body for this as well. Now we need to visit each of those again. Let's just for time's sake, we'll just do this again. Child of node, body, node, visit, child, body, push, node. Next one is return statement. We don't have any one of these. This is why I love that. I love this workflow, like being able to get these errors, because it's just like, what's next? To do. Easy, easy, easy. This one's super simple. It's just return. As soon as we return that, guess what? Boom, it works. Now it is not being passed. Let's see here. Pass that there. Now we get the return, and we're not yet returning the value, right? So that's next. We need to actually visit the argument. So visit node argument. We're going to get the error again for numbered literal. This one's super, super simple again. Hopefully you all agree that this is simple. So I32 const, this is outside the scope, but WebAssembly has the concept of I32 or I64 integers, and they're not signed or unsigned. You have to handle all of that. There's tons of documentation not related to WebAssembly that you can learn about, 32-bit integers, 64-bit integers, those sorts of things. But you do have to actually handle it. There is no number. There's integers, there's floats, and those sorts of things at this lower level. So we now need to thread the argument through, which is the first argument to here. And now it actually put the argument here. Now you notice we're still not getting the actual result, and that's because we have the type hard-coded to be none. So Binaryen knows that there's a validation error, and so let's actually make sure that we validate our module to make sure that we in fact are generating valid, and then we would get an error. We would say error in function main, function roles result must match if the function returns, and then it gives you the WebAssembly equivalent, which is tough to read at first, but eventually you get the hang of it and it becomes second nature, just like a lot of things. for now, because we don't have a type system in place, we have no type checking or type systems at all, let's just hard code it just for simplicity, because the only thing our JScript can do is actually return numbers. So we'll hard code it to I32, and boom, we get leaped. And just to confirm that this actually is indeed working, we can change this to like 9,001. It's over 9,000. And whoops, that was way over. That overflowed. That was actually a really funny example of overflowing integers. But whoops, so there we go. We got really big 9,999,999. And remember, you can do another one. So you could say another, and this one's going to return leap. And we can call it as well. So we get the first one, then we get the second one because we're calling them both. And voila, you have a programming language, a very simple toy programming language. You know, adding conditionals, adding variable declarations, type systems, all that sorts of fun stuff. There's a lot of resources about it. It gets much more complex, but the thing I think that this shows, and this is my reason for loving compilers, is that compilers are all about building blocks on top of each other. Like almost all languages, once they become non-trivial, no one, not even the original author, like the original language author, could explain how everything works on the compiler because it gets sufficiently complex. But the beauty is everything just works in combination because of these sorts of patterns, like the visitor pattern and the parsing and how all this works. It's this building block of it just magically works. And that really, when I first came across this sort of thing and when I first started making my own languages, it just super, super excited me when I was like, wow, I can just, like, I didn't have to do anything. I can just add another one and say foo and then return, you know, 13 or whatever, and change this to be foo, and boom, you know, it's all outputting. To me, that's really exciting. So I hope that was helpful for you all. I'm going to stop sharing, and cool, sweet. Awesome. So I just wanted to thank everyone for having me on. And if you have any questions about like writing compilers, language design, I'm particularly obsessed with language design. I don't know why. I really, really, really love playing around with new ideas on languages. I personally have been working on a language called Jaguar for, I don't even know how many years, 5 years or something like that. It's kind of a toy pet research project type of thing. Not because I think it'll actually be used, it's just fun for me. And so if you want to get into those sort of things, slide into my DMs and I'd love to talk to you. So you can find me at _jphelps on Twitter. Thanks, everyone.